Hey, hello all. Welcome to another video on this data science with Julia. So, okay, yeah, fine. And what we are going to see today is like I'm just quite happy. Like I've made some progress in natural language processing, and what I've just done is I'm able to compare two texts and say that one text is more similar to another text compared to another. So in relativistic terms. So I'm just going to say how I've done it. Okay, so that's the thing. Of course, I'll be putting links to all this code and all those stuff, and so that you people will know, right? So yeah. So what I've just done is I've just gone to Wikipedia and searched for tigers and what to say. Of course, this is nuclear reactor. Okay, so I want to search for tigers. Let me just close this. Close that. Okay, stab, right up. Okay, right. Okay, tiger. And another one you have something called cat. Okay. Somehow cat is related to tiger, so that's the thing. So okay, so you have this cat. Okay. So what I'm just trying to do is I'm just trying to find out whether tiger is more related to cat or whether it's more related to nuclear reactor. Okay, that's what I was just trying to do. Okay, so anyway, let's see how I did it. Okay, so you just have this text which I call it as tiger text. It's about tigers. I just take the first three paragraph and just put it first three or first four. Yeah, I just put it right. And then what I just do is to remove punctuation, what I do is this is actually called as regular expression. This R and this string after that is actually called as regular expression. So this is one of the ways you build regular expressions in Julia. And possibly people who are just following this, what to say, um, playlists might not know what regular expression is, but the thing is yeah, you can Google for regular expression in Julia and read for it, or I'll just give a very simple explanation. Like what I'm just saying is, whichever is not a what to say, a Unix character. A Unix character is nothing but every character that's between A to Z, capital and small, and underscore. Okay, so this is not a Unix character. This apostrophe is not a Unix character. Okay, this comma is not a Unix character. Yeah, that's what I just think. So and this once again this dot is not a Unix character. That is full stop. Okay, so brackets and all those stuff. Okay, these brackets and all are not Unix characters. Okay, so that is you don't give these characters in Unix name or something like that. Okay, so if you want to know about Unix name, yeah, Unix name, right? Oops. Uh, Unix name. So usually you will only give username and Unix name and all those stuff. So yeah. So I'm not sure. So no, I'm not sure. Okay, yeah. Anyway, this one removes any other character than A to Z. That is capital A to capital Z, small a to small z, and what to say? What? Okay, and what to say? And underscore. Okay, this one matches anything other than that. Okay, so and it just replaces it with space. So all these things will just get converted into space, and that's the thing. So and this dot, this brackets, and everything will get converted into space. Okay, don't get confused with the slash and. That is another thing. That's a new line thing and all those stuff. So now we have just got all these things without any before and all. If you look at before videos, this will have a bracket. Okay, so that is like bracket Panthera it will be, and similarly the tigress will be like tigress bracket. Okay, in the previous videos, but now we have just removed it. And then what we are just doing is, okay, we are just taking this thing called text without punctuation. We are removing all punctuations and all those stuff and using this replace thing in Julia. And then we are taking this text without punctuation. We are lowercasing it. So it doesn't matter whether it's uppercase or lowercase. In English, it just means the same, right? So, and then we are just splitting it so that it gets split into words. Okay. So, and that's the thing. And we have stop words. As you know, like we have this data folder, and this data folder we have the stop words and all those stuff. We have stop words, so we read that. Okay, we just store it in a vector, right? And I think you would have seen this in previous videos. So we are removing stop words. So we are removing stop words from words. Okay, so and that's what we are just getting. So they are around about like what to say 354 words, and after stop words are removed, like it's 187. So good thing. And now we are just importing this thing like mllib and dictlib. So what we have developed in previous videos, we have just importing. Okay. So unit vector. Okay. So the unit vector. Okay. The counter, from mllib, it just counts the number of words and you'll just give, and that we are just converting into unit vector. Okay. So just imagine the power of the libraries we have just developed. So I shouldn't say unit vector. I shouldn't keep saying the name vector. Okay, dictionaries. Okay, dictionaries. Okay, so that's what we are just doing. Okay, so vector is different from dictionary. So now we are just doing the descending stuff. Okay, so this yeah, I guess this name is also deceiving. Unit word vector. Okay, so but yeah, but yes, what we are just doing the descending stuff, and we find that tiger is more prominent in text about tiger. Of course, what else do you expect, right? So and what to say? Next is range is prominent. I don't know whether it has higher range or lower range. Next, population. So I don't know, higher population or lower population. South, I don't know what it means, South Pole or something. But yeah, but it kind of gives mission an idea. Like, okay, like what are all words is more, what to say, prominent for tigers, of course, predator. Okay, so, and yeah, and all those stuff, right? So now we can just plot it. What I'm just doing is like, okay, I'm just putting x and y as empty vector. And descending unit attributes, we know, yeah, we have just sorted it in descending order. I'm just taking 20 of them. Okay, so and pushing the second value to x. The second value is nothing but the words, the tiger, range, population, and so on. And the first one, yeah, all these values gets pushed to y. Okay, so that's the thing what I'm doing over here, right? And yeah, I'm just printing x and y, and now I'm just plotting it. But of course, I'm not happy about this plot because look, the tiger should be marked over here. It hasn't been marked, but of course, that's how this Julia plots behave. And I'm not really well versed at plots. I can use it for some purpose, but no. So that's the thing. But yeah, you just see like tigers and then range, and then it's just, I think population is third. Population, south, and after south, okay, habitat, okay, and then it just almost flattens. And if you go more, it'll also decrease more. So something kind of like exponential, it just goes. So that's how it is. So we have just converted some text into unit vector, and then what to say? We have just done it, right? So I just want to explain the next thing. Yeah, it's going to be a bit long video. I don't know. I'm not sure. So that's the thing. So the next thing what I just did is I just took the same text. Okay, so the same stop words. Okay, and what to say? Remove stop word function is the same function. I just included these both libraries. Okay, mllib and dictlib, and I just put this text to unit vector. So you just give the text and stop words. It does all these operations that's been done over here, right? So and yeah, I like to go step by step, so that like with what to say, and each step should be really anchored, and then yeah, I'd like to take the next step. So that's how it is. I just developed this function called text to unit vector. You just give any text and stop words, it will just give a unit vector. That's the thing, right? And that's how it is. And next, what I've just did is like I've just developed a library called mllib, NLP-lib, right? So this includes mllib, dictlib, okay, and I've just put these two functions in it, like what to say, this remove stop words and text to unit vector, right? So that's what I've just done, right? So now we have got a NLP function for us, okay? So where we convert text to unit vector, okay? So and yeah, I'm just testing this over here. So almost the same thing, right? I'm just including the NLP lib, right, over here, right? And then I'm just taking the stop words. Okay, so there is a text. I'm no longer calling it tiger text. Okay, so anyway, and then yeah, I'm just testing it. So the thing is like if I include this NLP lib and if I try this, it should work fine, right? So this is the next step what I just took. And now is the final thing, okay? So like I just have this tiger text, okay? So okay, some text about tiger, and next, what to say, like I have a text about cat. So I just took these texts. I just removed these one, two, and all these things. Okay, so like, I don't think they are important, right? So they make no sense to computers. Okay, so I just took text about cat. Okay, so I'm just including the NLP lib, and yeah, of course, I'm taking the stop words, right? And this is a tiger dictionary, text to unit vector tiger dictionary, and text to unit vector is cat dictionary. Now we know the dot product, right? The dot product, we have it in dictlib. Okay, so dot, where is this dot? Okay, this one. Okay, first dictionary, second dictionary. If you are not familiar, watch the previous video in this playlist. Okay, so that's the thing. So so yeah, we just have this what to say, dot product over here. And so tiger and cat, so this gives some kind of measure of similarity. Okay, so now what I just do is I just take text for nuclear reactor. Okay, so this is what I just took. So nuclear reactor, right? Okay, and then what I did was, okay, nuclear reactor, I just converted it to unit dictionary. So using this function like text to unit vector. Okay, so that's what I just did, and with the same stop words. And now I just did a dot product with tiger dictionary and nuclear reactor dictionary. So if I look at its 0.0038, so imagine like cat is far more related to tiger than nuclear reactor. Okay, so it's kind of 27 times. Okay, so the cat is this one and this one. And let's see, let's think something of what to say, steam engine or something like that. Okay, right? Steam engine. And let me get it from Wikipedia because it's no copyright. There is copyright, but the thing is like yeah. Let me take steam engine. So and, okay, steam engine text. Okay, right. Okay, so I'm just putting this thing over here. Oh, but why it's? I think I need to remove all these things. To remove all these things. Yes. Okay. So I have this ugly looking bracket 2, and I don't know where this ugly looking bracket 1 is. Okay, this thing is a bit annoying. It's difficult to click over here. Okay. Okay, I just take this out, and where is this bracket 1? Like, I just want to make it more, what to say, more friendly to computers. Right, so that's the thing, right? So I just have the steam engine text, okay, right? And what happened now? Okay, okay. So I need to take all these things out. Okay, fine, fine, fine. Okay, so yeah, you shouldn't have like double quotes inside double quotes string. Okay, so all those stuff, right? So that's the thing. Okay, so now what I just do is like, okay, like steam engine dictionary. Okay, steam engine dictionary. Dictionary, and then let me put steam engine text. So I've got a dictionary. Now I'll just do a dot of, okay, nuclear reactor dictionary and steam engine dictionary. I just get something, okay, somewhat similar, okay, 0.16 or something. Now I just do something, a dot of steam engine dictionary and tiger dictionary, right? So yeah, steam engine is more related to nuclear reactor than tiger. Okay, so that's what I'm just getting, and that's how it is. Okay, so possibly, yeah, algorithm works. Higher the stuff is, the more better. So that's how it is. So looks like our algorithm kind of works. So anyway, so that's how it is. So that's how I just did it. So hopefully, yeah, like you just have some kind of measure of comparing two texts and something. Possibly, I might include like something like a dot function, or what to say, text comparison or something like that, and which returns a number. So possibly I might convert this entire stuff into, just give two texts and stop words list, and you'll just get how close they are and something like that. So that's the thing. So anyway, I just hope you watched and enjoyed this video, and possibly just try it out and see how to do it. So as we build libraries and as we just go on, things will become far more easier, and we are abstracting everything, and maybe, yeah, we'll be building very, very good libraries to do natural language processing or machine learning. Like, yeah, so yeah, anyway, that's it. I'm very happy. Like, I can put it in my data science book. Yeah, if you don't know, like, I'm writing a data science book. Okay, so possibly this is quality enough to put it in my data science book. So this is it. So you can read it online, download PDF, EPUB, or whatever. So that's the thing. So yeah, so I've just started. Like, I've just started, and I need to do a lot. And that is there. So I'm just porting it from my blog over here. So right now porting, but all these what to say, videos will also what to say, will get converted into text and go into my data science book. So that's how it is. So I think I've got something worthy of for my data science book and all those stuff. So I'm happy about it. Anyway, thanks for watching this video. Hope it was useful. Like, subscribe, whatever it is. And anyway, thanks for watching.